Hello everyone. In this video, we'll be walking through a full demo of the Resource Circularity engine. We'll start by importing our building geometry. Hit Upload Model to bring your final model. You'll immediately be prompted to anchor your site. This tells the web app to read your building layers and set the lowest plane as the ground floor. Over on the left, you can see all our imported layers, and we can easily hide the ones that we don't need. So let's zoom in. Because we anchored the site, the engine dynamically understands your geometry. It knows exactly which face is the south facade and which is the west roof, for example. Up top, we have the building and neighborhood tab. Selecting neighborhood pulls in your surrounding massing to calculate site-wide agricultural opportunities. For this demo, we'll just focus on the building. Next, we move to the Site and Climate tab to pick our location. I'll enter Vancouver, Canada. Instantly, these 9 cards populate with localized climate data, specifically relevant to growing food. You can also have the option to override this data with your own custom EPW weather file. Scrolling down to building configuration, we define the building type. We'll select multifamily residential for this particular example and set the occupancy to 120 people. Right away, the engine estimates daily gray water and organic waste generated based on this specific topology and occupancy. All are editable. It also projects the sheer volume of crops required to feed those occupants, comparing it against what the building is actually producing, which is currently 0 because we haven't added any systems yet. Below that, you can set your MEP and roof reserves, as well as contextual set. You can enter these manually or just hit auto to let the engine generate them for you. This brings us to the dynamic opportunity area. The Resource Circularity engine scans your building's orientation, climate, and context to determine viability. It takes it a step further even by scanning the envelope to see exactly how much area is optimized for food integration. In this case, we have around 34% viable. And since we don't believe in a black box tool idea, every backend calculation is fully visible for us to review. Now comes the really fun part, the circularity rings, as we call them. We have 4 entry points to start modeling your systems. You can start from zones, systems, crops, or resources. You can enter through any gate you like. Once entered, it anchors your design and builds out the full cycle. Let's start with zones. I'll select the ground level. Now it prompts us to choose a system. I'll select a ground level greenhouse. You can browse local suppliers, but I'm going to just draw it directly on the building footprint. Once drawn, the engine calculates a standard height and provides critical data. This includes structural load, baseline water and energy use, and embodied carbon. Every number is anchored to a reference research paper and is entirely editable by you or the consultant. Next, we add our crops. I'll add leafy greens, maybe some strawberries, and tomatoes, just for an example. Because you can stack multiple systems in the same zone, let's also add the proprietary Perkins and Will pod right next to it. Let's also max out the leafy greens within this pod. The engine immediately flags that we have 2 paired systems within this boundary. If we scroll up to the rings, you'll see it has captured our 1 zone, 2 systems, and 3 crops. It also highlights a warning. If you click reveal our circularity gaps, because we haven't allocated any resources yet, it shows our current deficit in water, energy, and carbon. We can balance these out in the resource tab, and we can take a closer look at this tab in the next video.